All right, number 3 associated with practice problem A. Emily passes a soccer ball 6.0 meters directly across the field to Kara. Kara then kicks the ball 14.5 meters directly down the field to Luisa. What is the total displacement of the ball as it travels between Emily and Luisa? So a couple of the things we know here, we have 2 different displacements. So let's just draw coordinates. Now we're playing on a field here, okay, and so you want to establish which way down the field is. Okay, which way down the field? It doesn't matter. It really does not matter which way you define down the field, as long as it's consistent with the rest of your problem. So down the field, let's see, which way would I go? I'm going to say that this is going to be down the field. Okay, and then this is going to be side or across. Okay? So what we're going to have happen is we have a pass directly across the field. Okay, so this is across the field of 6.0 meters. And then Kara is going to kick the ball 14.5 meters directly down the field. And again, I've chosen to have the positive end of the x direction be down the field. Again, however you define the direction is fine, as long as you're consistent throughout the rest of the problem. So that means this will be 14.5 meters. What is the total displacement of the ball as it travels between Emily and Luisa? So again, here's my resultant. So I'm being asked for a vector, that's displacement. That's going to include a magnitude and a direction. So in order to figure out magnitude, I'm going to be using the Pythagorean theorem. In order to figure out the tangent, the direction, I'm going to be using the inverse tangent function. So here we go. That displacement is going to use the same setup as the Pythagorean theorem. Again, I've already solved for, I guess it would be C in the regular Pythagorean theorem, but we're talking about displacement here, so I'm going to use D. So that would be 14.5 meters squared plus 6.0 meters squared, all square rooted still. And once we actually carry some of that stuff out, we end up with 210 meters squared plus 36 meters squared. We're still square rooting. Let's add like terms. So we get 246 meters squared. Again, still square rooting. Then when we actually square root it, we'll come up with 15.7 meters. So this total displacement has a magnitude of 15.7 meters. Now we need to find that angle, right? Which is this right here. Again, referring to the picture that we've drawn, our first move was passing the ball across the field and then down the field. So this is that angle to represent the total displacement. And that's important because tangent is equal to opposite. Okay, here's my angle, opposite over adjacent. So that is going to tell me 14.5 meters over 6.0 meters. Now, when I plug this into my calculator, it's going to give you a whole bunch of different significant figures. but I'm going to use two significant figures here because of that 6.0. That's going to end up being 68 degrees. But what direction? I guess this would be downfield from the side, right? It's downfield from the side. Our initial movement was to the side, right? So I established my direction to the side. That's my first movement. This angle is downfield, right? Moving this way, downfield from side. Now I could say this another way. This actually could be, what would that be? Again, I can find the difference between this and 90 degrees, and I could restate the exact same position. This would be to the side of downfield. Okay, that's another way to say the exact same information. Okay, so here is downfield. Okay, there's downfield going this direction. How far this way did I have to go? 22 degrees. Okay, 22 degrees. So again, it depends on how you start your drawing, and either way is correct as long as you're consistent with the same directions you established in the beginning of your problem.